Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. How are you, everyone? Hope everyone is doing great by the mercy of the Almighty Allah. So, this is the first video on SSC Physics, chapter number 5, which is named as State of Matter and Pressure. So, let's begin. The first topic that, as you can see, is written on the top left corner of the screen is pressure. So before we just dive into the definition, I wanted to build up the concept a little bit. First, you understand the concept, then inshallah we will go for the definition, how we have to write in the exam, okay? Before, whenever you are learning something, it's very important to understand the concept first. So let us try to do that. As you can see, there is a rectangular box on the screen, right? Okay, let us consider this one as a surface, maybe the surface of your reading table. Okay, let us consider this one is a surface. So while we are discussing pressure, two concepts plays very important role. One is force, another one is area. Okay, so at first talk about area of this rectangular box or surface. So whenever we are calculating the area of a rectangular surface, what we do, we multiply length and breadth. So what is the length of this rectangular surface? Let us consider this one 4 meter for now. Okay, we can consider that. And the breadth, let us consider it 3 meter. So from here, if I want to calculate the area, I just have to multiply the breadth and the length, right? So 3 into 4, it will give me 12. 3 4s are 12, and meter into meter, it should be meter square, correct? Okay. The numbers, we are just assuming. Okay, this number may vary from case to case. And let us consider that the force that is acting on this surface is 60 Newton. Now the question might arise, why do we need force? Because if there is no force is being applied, then there will be no pressure. Okay, force has to be there. Then when we divide it among the people or on the surface, that time we can call it pressure. Okay, inshallah we will get to that. Just for now, let us accept that the area of this surface is 12 meter square and the force that is acting on this surface is 60 Newton. Now I can obviously say that the force acting on total 12 meter square area is 60 Newton. And from here, if I want to calculate how much force is acting on 1 meter square area, can we do that? Definitely we can, right? All we have to do is divide the 60 Newton by 12 meter square, and that will give us 5 Newton per meter square. And you can see that I have written it equal to P, which represents the pressure. So pressure is equal to 5 Newton per meter square. Now you might be surprised. We didn't even get introduced to the concept of pressure. We don't know the definition yet, but we calculated the pressure already. If we learn or understand the calculation first, then it will become easier for us to understand the definition. That is why we are doing it in this way. So let us dive more into this thing. 5 Newton per meter square. What does this mean actually? Inshallah, let us try to understand that first. So this 4 meters, that is the length of the rectangular surface, I have divided into 4 equal parts. 1, 2, 3, 4. So 4 meter is divided into 4 parts. Definitely each part will be now of length how much? How much? Yes, correct, 1 meter. Okay, so this one will be 1 meter, this part is 1 meter, this part is 1 meter, this part is also 1 meter. So this 1, 1, 1, 1 together forms 4 meter. So now just like we divided 4 meter into 4 parts, can we divide the breadth 3 meter into 3 equal parts? Definitely we can do that. 1, 2, 3. So 3 meter divided into 3 equal parts. So each part will definitely be how much? Yes, correct, 1 meter. So now we can see that the full surface, the whole surface has been divided into small boxes. Now these boxes, can you tell me whether they are rectangle or square? Yes, again you are correct. These are square boxes. How? Square, the characteristic of a square is that all 4 sides will be equal to each other. So here you can see that the length of one side is 1 meter. So if this is 1 meter, that definitely this side will also be 1 meter. And you can see this side is also 1 meter. So definitely the opposite side will also be 1 meter. So all the 4 sides are having equal length. So definitely this will be a square. So what is the formula to calculate the area of a square? That is side square, right? The length of one side, we will put a square on it. So the length of one side, we can see that 1 meter. If I put a whole square on it, the area should be, if you take one square, it will be 1 only, and then meter square, correct? So we can write this square box as an area of 1 meter square. Can't we say the same for this square box also? And this one, and this one, and all other boxes, correct or not? Each one will have an area of 1 meter square, because all of them are square with a side that is equal to 1 meter, 1 meter, 1 meter, 1 meter. Okay, that's it. So now we understood that 1 meter square, what does this mean? Okay, the total area can be divided into small area of 1 meter square. Now on 1 meter square, how much force should be acting? 5 Newton. That means on this surface, this part, how much force should be acting? 5 Newton. That is what actually 5 Newton per meter square means. 5 Newton on 1 meter square. Per meter square means actually 1 meter square. Okay? Per meter square means 1 meter square. Like if I ask you per person how much money they are getting. So per person means one person how much getting, right? So whenever we say that per area, that means unit area or 1 meter square area, correct? The unit actually might vary. Here I have used meter. Some place you might see 1 centimeter square, 1 kilometer square. It depends and varies from situation to situation. Okay. So the main concept is trying to understand what is pressure. So 5 Newton on 1 meter square. Okay. At first we were given the information that on 12 meter square, that is the area of the whole surface, the total force that is acting 60 Newton. So from there we found out on 1 meter square how much force is acting. That is what is actually pressure. And same can't we say about this square box also? On this 1 meter square also, 5 Newton will be acting on each of the 12 boxes that we have here. 5 Newton force will be acting on each one of them. Okay. So that is actually the meaning of 5 Newton per meter square. And then you can see that we are trying to develop a general equation to calculate the pressure. How we can do that? If we take a look at this one, to calculate the pressure over here, what we did, 60 Newton. This one was divided by 12 meter square. Now what is 60 Newton? That is the force applied, which we are representing by force F. And 12 meter square, it is the area of the surface, and area is represented by A. So that is why to calculate the pressure, we divide the force by area. So F by A. Okay. Now from here, we will try to give the definition. I never want my students to memorize the definition. Rather, I want them to learn the equation, and from the equation, they should be able to write the definition themselves. Then only you can say that you have actually understood the concept. Okay. So if A is equal to 1 meter square, you have already noticed that whenever we are finding out the pressure, we are talking about 1 meter square unit. 1 meter square means unit area. Unit means 1. So when A is equal to 1, then what we can write? P is equal to F, because F divided by 1 is F. So pressure is nothing but force on 1 meter square area. This is what the definition of pressure is. Now let us take a look at the definition. The force per unit area. Okay. Now you might be asking, sir, why didn't you mention 1 meter square here? Because unit does not mean always it will be meter square. Unit means 1. But the area, the unit, it might be meter square or centimeter square or kilometer square. So it is in general safer to mention per unit area. Okay. So pressure is nothing but force, but on unit area. Okay. So that is our pressure. And the symbol that with which we are representing pressure, you have already seen, it is P. And the unit also you might have noticed here, that is Newton per meter square. But with that, there is another one unit is also there of pressure, that is Pascal, and it is named after a scientist. You might have heard his name already. Full name is Blaise Pascal. Probably he's a French scientist, I forgot. Okay, that's not important right now. So both of them are actually unit of pressure. So this might raise a question, what is the conversion rate between them? Like if I have 5 Newton per meter square as I have it here, if I want to write it in Pascal, how much it should be? It is actually the same. Okay, 5 Newton per meter square is equal to 5 Pascal. That means 1 Newton per meter square is equal to 1 Pascal. 2 Newton per meter square is equal to 2 Pascal. So both the unit are actually same. Okay. So inshallah, we will talk more about this Pascal and Newton per meter square relation in our future videos. Today up to this one, if you have any question, any doubt regarding the concept of pressure, or if you think that the explanation could have been given in a better way, then I cordially welcome all of your suggestions. Write in the comment box, and if you learned something beneficial from this video, leave a thumbs up. Thank you very much. Happy studying. Assalamu alaikum wa rahmatullahi wa barakatuh.